Hello, beginning linear algebra students. This is a video on using Gaussian elimination with matrix form. It comes from Linear Algebra with Applications, an open educational resource found at this website. So the question is a pretty scary one with fractions. So let's see what we can get some some equations from this and see what we can do with fractions. Okay, so I just started with the very first sentence. The school has 3 clubs, and each student is required to belong to exactly one club. So if we're looking at percent in A, B, and C, it has to add up to 1 or 100%. Okay, the second one. We've got to come up with, we have 3 unknowns and 3, so we've got to come up with 3 equations, 2 more. Let's look at A. So much remain in A, switch to A, switch to A. So 4/10 from A stay there. 2/10 from B go to A. 2/10 from C go to A, and it has to add up to the same number of people. This is starting to look like one of those iffy equations. Club C, I've done it with A, B, and C, different tries. Let me just do Club C. So 6/10 remain in C, 1/10 from B, and 5/10 from A. Now, half of A went over to C. And since it's unchanged, it's got to equal C. So if I'm looking at this cookie thing, and I'd really like a constant on one side. So how about I multiply by 10 and get rid of fractions? 10 on both sides. And then, oh look, I can combine like terms and get 5a plus b minus 4c equals 0. 0 is a fine answer. And if I do the same method, taking the marching rubber bands club, multiply by 10, and I can combine like terms right here and get negative 6a plus 2b plus 2c equals 0. So that gives me 3 equations. Now, I did try it with, like I said, with Club B. When I have all 3 clubs in there, we're missing 1 degree of freedom. So we need this equation. So I just picked A and C. I could have picked A and B, B and C. But I do need this first equation. So the matrix that goes with this is just the coefficients and the answers written in a matrix form, and it's just read straight across. So if it's just A, it's 1. That's the coefficient. If it's 0, it's 0. If there's nothing there, it's a 0. So looking at this thing, I can use the 1 in the first position to eliminate with Gaussian elimination the next 2 rows to kind of clear out the rest of this column, to make zeros. So if I just multiply that first row by 5, negative 5, there we go, and add it to the second row, and then put what's remaining back in the second row, I will have eliminated. See how that I've got a 0 in that first column, and I just put it in there, and so that wasn't the first Gaussian elimination. And then I can use the 1 again with this negative 6. So what if I just multiply it by 6? Add it to the third row. So did I say lines earlier? The textbook says lines. I'm trying to keep it rows, so you always think rows by columns. So let's see. So just multiply that first row by 6, the easiest thing. I have a 0, 8, 8, and a 6. And that's going to go right there in that third row. And I now have eliminated everything from the first column except for a 1. Now I can do the same with, I can start, make this a 1 and make these fractions. Or I can just say, if I multiply this one by 2 and add them together, 2 and 3, I'll get rid of this 8 right here. Now, when I wrote this out, I almost forgot the leading zeros, but they are there. So, -8, -18, -10, and that's going to feed right into there. Now, you can keep going and make this a 1 with fractions and this a 1 with fractions. I'm personally happy right here because I can solve and not have to worry about 9s and 5s and So I'll just take the last one, which is C. So -10C equals -4. Which is pretty easy, as C's got to equal +4/10. So I'm going to take that and put it back into, kind of substitute back into the next equation, which would be -4b minus 9c minus 5. So putting 9 times 4/10 is 36/10. And -5 will be -50/10. So combining with algebra, and that just went off the screen. I'm apologizing. So I have -4b equals -14/10. So that's +14/40, or 7 divided by 20. And since that's a fraction, I'm just going to make this c a fraction over 20. So 8/20. So I have b and c, and I can come back to the first equation, which is a. So a plus the 7/20 and 8/20 is 15/20. So a has to equal 5/20. And this answer was actually in the back of the book. I couldn't believe it. Oh, it was doable. And the next video, I'm going to show you why this equation, or this matrix right here, with the 1s and the 0s, actually gives you the same answer.